You can see it. No one. This is perfect.
Of the session. Over to the keynote speaker. Good morning to all of you all. Good morning to all of you all. Good morning. A warm welcome to the keynote speaker for the next session, Mr. Sudeep from CNT. My dear colleagues, yesterday itself I said I call all of you all as delegates because you are attending a very important faculty development and empowerment program. So how was the session yesterday? Not good? What was good? What did you learn? What did you learn? For the entire day you learned metaverse?
Artificial intelligence.
I didn't get you.
Artificial intelligence.
Artificial intelligence in metaverse. That is what you learned. So, what is metaverse? I will just take 2 minutes. What is metaverse?
Virtual experience.
Did we experience the did we experience the virtual metaverse? Yes? Yes, no. Did you experience? So how many of us are with laptops today? Can I see a few hands? Excellent. Well, we're just going to, I know my topic is a bit dry, as you all know that it is theoretical, but the next and the following session is going to be very, very interesting because it is hands-on experience what sir has already planned. Okay, getting back to the session. My session for the day is ethics of artificial intelligence, or you call it as AI ethics, ethics in artificial intelligence. When we say ethics, what do we mean? What is ethics? What is ethics? Loudly. If you don't know what is ethics, principle. Very good. For what?
Knowledge.
You are the ethics.
Exactly, that is what I understood. Madam, you are the ethics for the college. So, you follow proper rules and regulations. Don't ask us to do it because we are not ethics. You are ethics for the college. Ethics are certain principles, what we have, we feel that we have to follow it on a daily basis. Being ethical not only strengthens you, it also imbibes the knowledge which is required to go further. Ethics is not only in education, but ethics is in all the fields, all the sectors, wherever you are working, you are speaking, and whatever you are doing. Even we have the concept of ethical hacking. You have at least heard about it? Hacking itself is a crime, I suppose, but we have ethical hacking. Okay, so ethics speaks a lot. So for today, let us look into of how ethics is taken up in artificial intelligence. So I've divided my presentation in 4 quadrants. The first one is AI ethics. Then we get into steps to establish AI ethics. It has to be established. We understand what is the meaning of established. It is not there. It is not. It is created to be there, but we have to establish it. We have to see whichever points necessary. We are supposed to establish. The third one, key areas in AI ethics, and finally benefit of AI ethics. I wouldn't stop at this. I have got a few case studies which would definitely help you to understand how ethics follows up. Let us look into its definition. And I hope each one of you will be focused on the video. So I need not read. I will only explain of what is put up over there. So when I say AI ethics, it is going to be divided into 2. We say robo ethics and machine ethics. What are robo ethics? When you are going to devise a robot, you have to see that ethics will be followed. It should not be for destruction. It must be for some help. Okay. So that is the main meaning of robo ethics. When we say machine ethics, I think yesterday in the first session, Dr. Prahalada sir was telling about agents. Yes? Can we recall? Sir was talking about agents. Agents in AI, artificial intelligences, you have a model of yourself. All of you all know because you are already into the artificial intelligence world. So we just see that this machine ethics deals with the behavior of the agent. The behavior of the agent should be in such a way that it does not disrupt others, hurt others' behaviors. Okay, this is what we call it as. So now this forms the AI ethics. So if you look into each one, can you read? Yes, a little bit. So we say accountability. Accountability, it is not accounts in your commerce. Accountability is who is responsible for any act in artificial intelligence, who is going to be responsible. Next, we have the fairness, transparency, privacy and data governance, reproductivity and explainability. These are the basic AI ethics what we are going to learn for the day. Let me put it up in words, in simple words, so that you'll understand better. It's exactly what you're going to do when you're going to plan. And let us understand that when we say AI, it is the coding which happens based on that where execution takes place. Am I right? Loudly. Oh, very good. So now I have given both of what are the features and what are its explanations. So when we say accountability, we say what are you defining, and whatever you define only works. Something else is not going to work. So when you are defining itself, you should see that you are ethical. So the first one, we say context. I am going to write something, I am going to write a code. I want that for execution and it is going to help somewhere. So you say, for what am I writing this? What is the main aim of writing this? Simple example would be all of you have come over here for the FDE. Why am I coming here? For what? What I'm going to get back? What is my takeaway at the end of the session? So the takeaway at the end of the session would definitely depend upon what input is given to you. If proper input is given, when you walk out, you say, yes, this is my takeaway for the day. If the input is wrong, you will say, I have not taken up anything for the day. I couldn't understand anything. There was nothing that I got it from this session. Okay. So fields in which an accountability relation is established. Accountability, I said, it is who is going to be responsible. So that is the first purpose of why you are building artificial intelligence. About what? At the end of the session, definitely I have a few slides which will tell you why we are taking up this artificial intelligence to such a great extent in today's scenario. So there you can recall the statement of range. To what range you are supposed to implement it. So the tasks like actions, services, decisions, assessments taken by the accountable agent. So the agent is the artificial intelligence which you are going to introduce, and that agent is going to be accountable. For what service he is going to be accountable, for what action is going to be accountable is what you have to define. Agent. Who is an agent? I don't want to read there or explain. I think yesterday we learned about who is an agent. Who is an agent? If you want me to just talk and walk out, there's no problem. It is better for me. Who is an agent? Can anyone tell us who is an agent? Yesterday we saw, no, when Dr. Prahalad was explaining to us. And I don't think I have to explain what is an entity also. Entity? Yes, no. We know what is an entity? We know what is an entity? Good. Entity who exercises the delegated power. So we have got a person, a replica of me, myself, and the person is called as an agent. So yesterday I was telling you about the accident. Either it is for or against. It is a good thing which has happened or it is an abuse. The person who is going to be affected is called as an agent. So next we have forum. To whom? For whom are you designing this? This is accountability. These concepts sound accountability. For whom are you designing this? Standards. According to what standards? You must have your own principles. You must have your own rules. You must have your own regulations on why I am doing this. Process. How it can be done. There are a lot of processes which you'll be learning in the next and the following sections. What is the process to be followed? I cannot have a shortcut. I must go through the proper channel if I want to complete this. I've already said I've got some rules, I've got some regulations to be followed. Finally, implications. What happens after you see that this is executed? So the major person who is going to play a prominent role in accountability is the person who is going to be the major agent, what we call it, artificial intelligence. So that is the first. Second one, we say fairness in AI. These are all a bit of context, what you have to understand of how AI ethics works. Any processing of personal data using AI, which leads to unjust discrimination between people, will violate the fairness principle. I'm using some data. Example, we can just imagine on phone numbers, which is just with everyone today. For promotional reasons, they call us, they ask us, it is not like they're requesting us, it is not, it is an information. So is that data which you are going to be. So processing of personal data using AI is very, very important. So why we call this as fairness, and it is one of the concept in AI is when you are using the personal data of somebody else, you must be clear of how you are using it and for what you are using it. Phone number, example, I said phone numbers are given to everyone for promotional activities for marketing. But how are they using the numbers? Is it only for the promotional activities or for any other reason? If they are using it for any other reason, they are not fair in using the data. This is what we mean of fairness in AI. These include very, very important, and I've got a case study also for this. Non-discrimination. AI should not be a platform to discriminate about equality, freedom, dignity, etc. So when AI is being designed, you have to follow a fair, you have to follow fairness in the data what you are going to receive. Please try to recollect whatever information you're going to give to the data, giving to the AI concept is all data. So this data from where you are getting it, how you are using it, and how you are giving it to people to use it. You receive a fair enough data, but manipulate it and present it in a different way does not call in for AI ethics. Transparency in AI. Of course, we all know about this transparency in AI because I feel all of us are from the computer science background only. Artificial intelligence systems make decisions why they produce specific rules and what does they are used, what data are they are used. So just I was having a talk. At the end of the day, when you're going out, if you have got the proper data, you can use it for other purposes. But if the data itself, what you have received, is not compatible to your thinking, then the data what you have received is waste. So this transparency of what data you have received and how you are going to process it in AI becomes very important. It's like providing a window into the inner workings of how AI processes it. Let us take an example when we are going to define a table and define a view. Where do we define tables and define views? Databases. Okay. So when we are defining a view, the view is a part of the table, but not the table. So when you are manipulating or you are entering some data or you are updating the view, what gets updated behind? The table gets updated. Okay. So although you are given only a view of the table, you cannot manipulate and give wrong information because the original information already is there. So when that original information which the data is there on the table and you are viewing only for the purpose for which the view was created, it is exactly like that what we do with AI. So it is just a window and you are understanding the inner workings of AI because the data what you have collected is perfect. Helping people understand and trust how these systems work. That is what is transparency in AI. So what are the best practices that we can consider in AI? Transparency. Make ethical data collection a priority. Data what you collect should be ethical. Don't take false information to devise and create manipulation. Offer clear documentation. Involve diverse voices. Clearly define AI objectives and priorities. Tell them I'm using this data only for this purpose and beyond this your data cannot be used. Implement continuous feedback mechanisms. Very important because even when you're taking up a project, you do require feedback so you can improve upon. That is what we are going to learn in the case studies which is going to follow. Follow established standards and guidelines. You put up your own principles and say beyond this principle I am not going to get further. I will stick on to these principles. Understand? You are, when we call AI, you are working with the feelings of a human being. his emotions, his values. So don't play with it. Have a proper rules and guidelines to follow. Privacy and data governance in AI. Privacy, whenever data is going to be given to you and you are going to implement it in AI, see that it's protected, especially in the government organizations, where it should not be, it should be kept confidential and it should not be shared. So these are the two things what you have to remember when you're planning to decide, when you're deciding to work on AI. A brief, I'm just going a little bit faster because we are already late. 1 second, I want to get into the case studies, which is really very important. Reproducibility, it refers to the ability to achieve the same or similar results using the same data set and AI algorithm within the same environment. So the data, whatever you are going to take, it can be used for multi-purpose in the same environment. But how ethically you use is more important. Data set refers to the training data set that the AI algorithm takes as input to make predictions. See, when I speak about all this theoretical part, it may be a little bit difficult for you to understand. But let us understand as raw literature when we are looking at the reproducibility. It consists of model type, model parameters, and hyperparameters, features, and others in the code. So when you are making up the code, you are using the same data set for different purposes. How you use it for different purposes ethically is more relevant for reproducing. Explainability, any algorithm that you're going to write for the execution, please see that it is explainable. You are able to define for what purpose you're using this particular option or this particular data, which is very important. Certain classes of algorithms, including more traditional machine learning algorithms, tend to be more readily explainable while being potentially less performant. You have got 10 options in an algorithm, but all the options doesn't get executed at a time. It has to be there, and any one particular option may get executed. So that is the meaning of explainability. So although it is not getting executed every time, still it should be to explain by itself. So be careful when you're choosing. AI ethics, again, very small steps to see that you can plan how ethics can be in AI. So those small steps are establish ethical guidelines. This is the same thing whatever we do in our projects. Before getting into a project, we write what are the rules to be followed, how data is to be collected, from where data is to be collected, and how the data can be used. Same way, have proper guidelines. When we say artificial intelligence, it is going to be used in different ways, different ways. The sectors which are using artificial intelligence, it is just immeasurable. Simple example, if you think about Chat GPT, how many of us are using? I don't. For what? For what? I would love to stress a few minutes on this. For what?
Do my homework. Do my homework.
Assignments, exactly. Assignments. Then, you know how ChatGPT comes to me? In which form ChatGPT comes to me?
Answers to the assignments.
No, it comes as a letter. Good morning, madam. Hope you are doing fine. Hope you are doing well. What is the purpose of using ChatGPT? I don't understand when I read the first line. You're not writing me a formal letter. You're writing a requisition. You're writing an application of requisition. So for requisition, you ask the person, are you fine? If you are fine, I will request you. If you're not fine, I don't request you. And there are paragraphs which is not at all relevant to the request. This is the place where we think about ethics. There are a lot of things available on ChatGPT. What is relevant to me is more important, that I look up to it and I take it and use it. It is not that whatever comes up there, I just give a line, a request. I want to write a letter of recommendation and it gives 100 pages. You take up all those pages and present it. It is clearly defined that you have taken it from ChatGPT. The first line itself tells me, oh, what is the benefit of this? What is the benefit when you're taking all your text from the ChatGPT? According perception is different, but according to me, you are completely forgetting the use of language. How many of us write the alphabet U for YOU in your texting messages? The same thing comes as answers to us when we are evaluating your papers. Maximum or most of the faculty members, professors, associate professors, everyone would accept what I say. The answer scripts are full of short forms. From where did it come up? From the language that you use to text your friends. I don't want to be here when I would have a day to witness all answers in shortcuts. All answers. Why? Because you are forgetting your language. The same impact will be there when you are using your chat GPT. You ultimately don't allow your brain to work. You don't give any work to your brain. You want an application, just type there, you get the application, copy, paste, write, submit. Over. At the end of the day, you don't know for what you have submitted. What have you written? If there are some words which are not ethical and the person comes back to you and asks you, what does this word say? Is it I wrote? Was it in my letter? Not at all. I don't use such words at all. Ask my friends. I don't use this word by conversation. Then from where did it come? Many of us have forgotten language. Many of us have forgotten grammar. Many of us have forgotten the spellings. The spellings are no more there. Grammar is no more. Even when you're texting on your WhatsApp, you get the grammar immediately. So you just click on that. And you don't know the context for what you're using that word. Is it relevant to the conversation what I'm going to have on the WhatsApp text message? I don't think of it. It is given by default, so I use it. That should not be the purpose of why we are using artificial intelligence. So the first one. Establish ethical guidelines. These are all for new people who are getting into coding, or students who are getting into coding, of how this AI to be used. Ethical guidelines are very, very important. When you are writing something as a code, it gets executed and it should not be hurting the person or hurting the person's behavior, which is very important. So please see that proper ethical guidelines are framed. Identifying existing infrastructure, but a data and AI ethics program can leverage. What is the scenario or what is the context in which you are going to present yourself? A data and AI ethical risk framework that is tailored to the industry. Why I'm specifying on a few points is depending on the industry in which you are going to implement your AI, be very clear. Use it for that particular industry. You're writing a letter because you have, say, you have taken up with an accident on the road and you are writing a letter to the police station, the authority, and you say, hope you are doing fine. The first line. How it would be? How it would be? You are already committed a crime and you go there and write a letter, hope sir, you are doing fine. I am doing well. Not acceptable because it is not according to the context. So look into the context, which industry, which place, which situation, which context you are going to use these words. Change how you think about ethics by taking cues from the successes in healthcare. Healthcare, AI has really done very beautiful things and we will get to a little bit of it also. So we say take cues. Cues is take the clues from them. How they have devised it, how they have been successful. Based on that, you can implement it into whichever industry you are in. Banking sector has taken up AI very much. The transactions which happens with a human intervention takes a long duration of time, but with AI it is just a few seconds. It's not necessary that you have to get it wait even for a few minutes. In seconds, your job is done. Encourage public engagement. Why we require public engagement? This artificial intelligence is going to be devised for the public. It is not to be kept in secret in one company. It is going to be globalized. So whenever you are planning something, in the initial stage itself, code it, give it to the people who are going to use, and then take their feedback so that still you can improve upon what you are doing. It is not that because it is the ultimate people who are going to use it. It is not you who are going to use it. Exactly the same way, whatever you do your coding or whatever you do your applications. Applications are devised for the other people to use. So you devise an application according to your perception and according to your situation and give it to them will not be applicable. So what do? We give it to the user, ask the user to use it, and if there are any implications that can be changed, definitely at the back end, you are the people who are going to code it. Establish oversight mechanisms. What do you mean by oversight mechanisms? This is not literature, it is a bit of technique. What do we mean by oversight mechanisms? Human-centric approach requires implementing AI systems safely and reliably to benefit humanity with the aim of protecting human rights and dignity by keeping a human in the loop. So this is establishing oversight. It is not systems must be designed. We are designing systems with the help of AI and developed in such a way that they can be effectively overseen by natural persons. We are devising something which is unimaginable, but it has to be found out by the existing human beings if it is right and it would work right for the other people. Many a times we have not seen into this, like example what I gave you, the car accident yesterday. Oversight mechanism was not used. So what happened? They had different levels of operation of these vehicles. If at all they had an oversight mechanism, if they had a feedback system, and if they would have given to practical human beings to use it and give a feedback where it can be improved upon, definitely we would have had all cars which would be autonomous as of now. No drivers. It would be driven by itself. But this mechanism was not used. Because they did not use the oversight mechanism, they had to get into different levels of automation of vehicles. That we will just look at further. AI in AI ethics, key area of AI ethics. It is just a previous slide what I explained individually. Rather than explaining more on this, a few case studies may definitely give you insights about ethics. Bias and fairness, we have got a case study on this with Amazon. Privacy and security, transparency and explainability, which was already explained slides before. Accountability, safety, human dignity. Human dignity is very, very important. You cannot demean a person to say that I have used artificial intelligence in this particular sector. Social and environmental impact. How does your design impact the social awareness about the people is also very important. So see, these are the key areas of where AI ethics should be doing a groundwork before AI is getting into the system. What are the benefits of AI ethics? Increasing transparency, because maximum of the AI or maximum of the coding what is done, it is not transparent. We don't know how the coding is done, but we know only the execution part or the result part. But with AI, with ethics, definitely we have to understand of what is actually happening and how it is going to be implemented, which falls into place. Fostering innovation. Earlier days, AI was used for a very limited purpose, but now it is just exuberant. Almost in all the fields we have got AI, including AI in education also. You all know how it is used in education? How is it used in education? Anyway, I don't want to stress on that. We have got a session tomorrow by your SVP, sir. You will definitely understand better. For the betterment of education, when we say AI is getting into an education, it is not another person like me who's going to stand there and explain how you make your things work faster. Nowadays, if you want to prepare a PPT properly with your own mindset, you require minimum 5 days, 1 week. around 2 or 3 hours per day. That is what I do. Copying, taking out PPT from somewhere and just presenting it doesn't make sense because I don't know what is happening. But on my mindset, whatever I have and I'm going to put it up on the PPT, I know how to explain. I did not even look at the slides. So minimum 5 days, 2 to 3 hours per day. But your AI will give you the terms and concepts what you can use in your PPT. It is not that it should be used. It can be used depending upon what you want to present. Okay. So there your work is easy. That is why we say AI is into education on the positive terms. Then we have fostering innovation from a very small industry or small place where we use AI. Now we have flourished it to such an extent. Maybe after a few years, it would be difficult to see human beings in all of this, especially in the industries. Then human beings' job on artificial intelligence, robot related. So we are not going to lose jobs. Don't have the fear that we are losing jobs. We are going to be more intellectual in coding. One person codes for hacking, we have got the other person who codes for ethical hacking. Okay, so it is just the extension of the knowledge what you have to plan. Enhancing privacy and security, promoting trust, reducing bias. We'll just go through a few case studies. The first case study in the healthcare industry. I will have to read it because you have to ponder a few minutes on this case study. US health providers using artificial intelligence algorithms to guide health decisions, such as which patients require extra care. So they had devised an artificial intelligence to say, of course, it is from US, the blacks and the whites, to see which patient requires more care. While coding, there was a problem and there was a challenge which was not adhered to. At the end, when AI was executed, as per need. Although they were critical in nature, although the patients were critical and they definitely wanted extra care, they were literally weakened. So it is not that artificial intelligence is not working properly, but behind the artificial intelligence, the person who was coding was not right. So let us go forward. Bias tends to reduce the more than half the number of black patients identified for extra care compared to whites. The primary reason for this is that the algorithm uses health cost rather than illness for health needs. Now we're looking at only the cost. It's not looking at the health needs. Less money is spent on black patients than white, yet they have the same level of need. Both of them are with the same disease, they are with the same medication, but still there is a bias between black and white. Thus, the algorithm considers it only that black patients are healthier than white patients for the same disease. So much care was given to the white patients rather than the black patients. So this bias has already happened, so they had to rework on the AI. Case study of banking and finance, I already told that we are already into banking and finance. Apple Card, the AI system of Apple is biased against gender. I don't know. Now in the society, we say we are equal, but still, the coding which was done for AI has done a lot of bias between genders, that is a male and a female. Again, it gets back to the coding. Offering significantly different interest rates and credit cards to different genders. They always feel that men are higher, so they got all the credit. They get all the credit cards, they get the upper limit, and all the women were demeaned. David Hansen, tech entrepreneur and founder of Ruby on Rails, claims that his wife received a credit limit lower than his, yet has a more favorable credit score. She had better credit score, but she did not get the credit limit. With traditional black box AI systems, it would be challenging for a bank to analyze and understand where this bias argument originated. Where does it originate? It is in the coding only. The way you have done the coding depends upon what is the outcome. So this is the second case study. Third case study is a little bit again biased in case of hiring. This was implemented, but Amazon could not take it forward as it was biased. They had the software because when you talk about hiring, you have to look into their qualification, their experience, and to which industry they are experienced with, which profile they are experienced with. Only then you can recruit the person. So this is a very tedious job for the HR to sit and uh, sort out the applications, whatever they receive. So as it is a TDS, and when you know when it is FMCG products, definitely you require a person who has got hands-on experience. So they devised a system, they had an AI implemented for recruiting people. While recruiting people, of course, we all of us know the gender bias was again brought in, where although experience is available, they could not recognize it. Definitely, this was a pain. Amazon attempted to leverage the HR teams using their AI recruiting and hiring tool. It allows organizations to make thousands of resumes and then select the top five. You can imagine thousands of resumes and select the top five. But in 2015, it was noticed that the system has a bias against women by rating candidates for software development and other technical positions. So, again, women. The reason for this bias is that the data that is used to train the system, you have to train the system because the system doesn't know how to work. You have to give more uh, applications, resumes, and see that it is going to be trained. It was trained on the last 10 years applications. Previous 10 years applications were given to be trained, thus observing the resume submitted pattern. I hope you'll understand that we have got a pattern recognition in AI systems. So there was a specific pattern which was given. There is a specific pattern what we give to the students to write an application, from to addressing and it goes on. So if there is a slight difference in the pattern, AI was not able to look. It could not recognize. Okay, so resume, most of those resumes are men. Therefore, there was a reflection of male dominance. So the 10 years applications or resumes what was given to AI, maximum of it what was scanned was all male resumes. So what it was understanding is male candidates are supposed to be getting into these jobs. So all tech industry was filled only with male candidates. They did not recognize the women candidates. This is what I said in the beginning. Data. What data do you get? That is what you get. What data you're going to receive, that is what is going to be the outcome. What data you receive for your analysis, that is the outcome of the result that you are going. So what do we conclude after understanding or looking into these case studies of different sectors? It is mandatory to check the system's fairness. The first slide what I used for what is AI in ethics. It may continue raising the social inequalities that must be managed. Required actions and regulations are mandatory to overcome these ethical challenges. So definitely every perspective what you have to implement for AI should be explainable. Again, getting back to whatever was already explained, wrong decision can have disastrous effects. Therefore, the adoption of deep learning is slow. Organizations often cannot confidently reproduce how AI systems make decisions. So when you're giving it the values of people, when you're giving raw information to the system, how it understands and how it executes still stands up as a challenge. This is another example. The death of Elaine Herzberg in March 18, 2018 was definitely a disaster. Autonomous vehicles without drivers, which are driven by AI, was pushing a bicycle across a four-lane road in US when she was struck by an Uber test vehicle, which was operating in self-drive mode, with a human safety backup driver sitting in the driving seat. It was autonomous and it was going on by itself and self-driving. He was there only to check for any accidents. She was taken to the local hospital where she died of serious injuries. Who is going to be blamed? What is the accountability when such things happen? So now, because of this disaster, later on, they understood where the problem was. This is very, very important. You deploy, you devise, and put up a system. At the same time, you must be ready to understand the consequences and see that you are going to rectify it. That is what happened now. Consequences, accountability was totally lost. They did not want to sue in the law or court of law. Is it the driver? He doesn't do anything because everything is automatic. Is it the AI? Then who is the person? Is it the company? So this remains as a question. Because of this disaster, we have started working backwards of how this automation had happened. Explainability came into existence. Level 0, moment driver assistance. Momentary. At that moment, if you want the driver to be in place, he is there. Features are assisted and do not operate the vehicle. Drivers must steer, brake, and accelerate. This was the first level 0 for automation. Automatic emergency braking, forward collision warning, lane departure warning. These are the 3 examples for level 0. Level 1, we have a driver assistance. So now we are improving the artificial intelligence given to the system. Driver is responsible for driving. When engaged, the system can perform either steering or accelerating braking. When is he busy? He wants to have some water. When is he busy? He wants to take out some records. He wants to see some other activity other than driving. So then the system takes the control. Adaptive cruise control examples and lane keeping assistance. This can be utilized. Level 2, additional assistance. System can perform steering and acceleration or braking when engaged. Highway pilot, example. Level 3, condition. Only during these conditions, automation can be used as, or else I as a driver am going to operate. System performs driving tasks while the driver remains available to take over. When AI-driven cars are put up on roads, they did not have the identification of a human being walking on the footpath, that is the pedestrians. It could not recognize. It would recognize only a block or an obstacle in front of it, and then it stops. But to identify that, and when it is not identifying, the driver assistance is required. High automation, fully responsible for driving, while occupants are only as passengers, and no driver is required. Totally automated. Full automation, level 5. When engaged, the system handles all driving tasks with you. Now the passenger are not needed to man over the vehicle. The passengers have to be just seated. Whatever conditions, the system will take it to pass. The system can operate the car universally under all conditions and at all speeds. So this is the 5th automation, 5th level one. Have you at least witnessed automated car in Bangalore? Not yet. It's already on. Only one vehicle is on. Okay. If at all you get a chance, you can see passengers, no driver. It is only the car because we are here. People are very safe. We don't want any disaster. So we allowed it to go on the road and see how many people watch it. And if there are accidents, I will not buy. If there are no accidents, I will see that I can buy. So that's all. Anything informative? The first thing is starting. Ma'am, please move on. It's time. Okay, I've got a small quote by Gigi Rometty. Some people call this artificial intelligence, but the reality is this. Technology will enhance us. So instead of artificial intelligence, I think we augment what? Our intelligence. Because whatever is there on computers today from the time computer is invented, it is all the human brain which works. Do you agree with me? It is only that I give an input, but the output is in a different way. When I give, for example, very old concept, when I'm going to give a 9-digit, two numbers to the computers, definitely I want addition to be done. It takes a few nanoseconds, but if it is given to me, it take a few minutes. But then the same, which are the other operations that I can go forth with, multiplication, division, etc., is done with a computer. So that assistance can be taken, but I cannot say that I myself can be invented and artificial intelligence can be introduced. We are still a long way to go with the values of a person to be drawn into the system. When you meet a person, if it is a normal person you're meeting every day, you have a greet, you have a nice handshake, and you say good morning. If it is a person, every minute, every second, every 10 times a day you're meeting him, you just wish him, say, hi, how are you? But if it is a delegate, if it is a person who's come for a specific reason into your favor, how do you treat him? You have got a different value for the person. You get up from your chair, you go to the place where the person is heading to, and you have an action. Can this value be given to the system? Can it understand? I want answers. Can it understand? Can it understand? Simply.
There is research being done on transferring emotional intelligence. So what we're talking about is EI.
Emotional intelligence is quite a long way to go. We have seen movies also that emotional intelligence was not be accepted. You change yourself. You change every time when you meet the audience, depending on which audience you are meeting. So all those characteristic features of whom you are going to meet is supposed to be given as an input to the system. Only then it will know how to represent itself and it knows how to react. But if you don't give all that values to the system, still we are yet in our research getting along. Emotional intelligence. Now we've spoken about AI. The next would come up with emotional intelligence. By the time what has happened, we are ready to watch. What will happen? Yeah. Thank you.
Regulation and policy of artificial intelligence is an emerging issue in order to maintain social control over the technology. Regulation is considered necessary to both encourage AI and manage associated risk. Our keynote speaker has given information about AI ethics on key areas such as best practices, privacy, and data governance and case studies. Thank you, madam. This comes to the end of session one. I request all the participants to for a tea break and return back exactly after 15 minutes. Thank you.
No what? Yes. We are having Wi-Fi problems. Just go to that link, http://ly python -. Go to that link, it will give you a zip file.
Yeah.
Just go to the link that you have. It's a Google. It will take you to my Google Drive that will ask you to download a zip file. Once you get that zip file, download it to your systems. Run the hash. I mean, you can trust me, but still run the hash. Okay? Yeah, just download it. You can download it from the So the first about say 45 minutes I'll do a theory. Just take you all through what computer vision is. Sorry man. I just wanted to get you on set up so that later on it doesn't take time. Not yet. I just wanted to set up. Okay. What I want to talk to you today is about us as people, right? So, when we as people, we need to actually understand what makes us people and what makes us different from the computers that we are using today. So, all of us have gadgets, all of us have laptops, we've got mobile devices, we've got tablets, we've got phones. And all of those are smart devices. But what makes us smarter than them? So, as what makes us human is the abilities that we have, right? And that is our ability to feel with our hands, our ability to feel with our skin, our abilities to smell, our abilities to see, our ability to hear, speak, and think, right? That makes us unique. That sets us apart. The ability for us as human beings to actually think decisions, make decisions, look at the entire experience that we've got right from the time that we're born. We're babies, we learn to walk, we learn to crawl, we learn to basically talk to each other. We go to school, we go to college, and then we're here. So we basically have that entire experiences right from the time we're born to the day that we have today, right? Through the entire ages that we've gone through. That was what makes us who we are. So giving that ability to a computer is what actually makes it intelligent, right? It's giving our abilities of sight, our sound, of thought. That's how artificial intelligence comes in, right? It's basically making the computers think that the way we do. That's how deep learning works. Deep learning is actually setting up the neural network as an algorithm in a computer in order to transfer the or mimic our human brain into a computer algorithm. That's the entire premise of deep learning. But what I want to talk about today is just this sense of sight, right? We take it so much for granted that we see the world around us. But how do we take that power of sight that we have and transfer it to a computer so that the computer sees in the same way that we see? Right? Okay, so anybody kind of needs help with the setting up part of it? So therefore we get into the hands-on session. Is everyone set up, running the initial, let me swap over to my, okay, when you download that, you basically get this setup file, the second one over here. Running that will basically start an entire process of download Python onto your system along with downloading a computer vision file. That's the OpenCV that we'll be using later on, right? I'll take you through a couple of examples as well so that you all can see before we get on to the hands-on session. But anyone's not got there yet? Everyone's reached there and able to download and is getting that console window, the black color window popping up with the process that is going to follow. Everyone's reached there? Yes? Okay, awesome, good. Okay, so we as humans can see, okay, but we see a limited wavelength. So we only see the 380 to the 750 nanometer wavelength, right? There are animals, there are bats, there are fish in the sea that you can see more than what we can. But ourselves as humans, we just see the visible wavelength. We don't see anything else other than the visible wavelength that we have. But the entire spectrum of shortwave to the long wave, right? Imagine the amount of superpower that we would get if we can see the entire thing. We can see X-rays, we can see gamma rays, we can see, we as humans can't. Cameras can, computers can, right? So computers right now or cameras have a better ability to perceive the universe around us than we as humans actually have. But still we're not able to actually give them the power, and that power comes from the processing, right? Our brains interpret those images in such a different way compared to just being images. So when we see the world around us, right? our brain automatically does these things. We don't even think about it. We basically see what, when we look around, we answer 3 questions. Inherently, we answer 3 questions. What are we looking at? Where those objects are, and who those people are. Right? Your brain automatically does that. We don't even, without even thinking about it, you are looking at it like, that is Christy ma'am over there, or that is my friend over there. How do we do that? How do we automatically make those recognitions? I look around the room, I see chairs, I see people, I see a camera, right? And I know perceptively where, what, and who. Those are the 3 questions that we automatically answer. And those are the 3 things that we need to transfer over as algorithms. The code we write, those are the abilities that we have to give a computer. And that's what the session is about. How do we do that? How do we actually keep it any more closer? Then it will go into my mouth. Is it too close? Too far? Not audible at all? Sorry. Okay, if I speak without the mic is audible? So basically the problem is with the mic then. Fine. So what I was saying is we basically do what, where, and how. So there are programs that we do and algorithms that the greater industry of ours has come up with, right? That give us the programs to answer those questions: the what, the where, and the how of sight. So we've got image classification, that's human eyes, and these are cameras. That's camera eyes, right? So basically, when we say what, it is image classification. It's what is the difference between a chair and a camera. We know the difference. How does a computer know that difference? And that's what we're going to learn about today. Where items are, right? We are able to automatically perceive where items are in the room. Now, how do we give that ability to a computer? And that in computer vision terms is known as object detection. So you have image classification, which answers the question what, and object detection that answers the question how, right? Then we have people. Now, people all look the same, right? All of us have eyes, noses, mouths. All of us kind of look the same to each other. But we are able to perceive that minuscule differences that identify who we are, right? How do we do that? And how do we transfer that information of making a differentiation between person A and person B over to a computer so that the computer or the algorithm can tell that difference between person A and person B? That is what we're going to do in person recognition or facial recognition. Okay? Alright. But before we get into that, I want to talk about images. Right? We basically take images for granted. We just accept the fact that what we see on the screen is what the computer is also seeing. But there are differences. Okay? And the differences that there are, can I use this mic? Is this mic better? Yes. Yeah? Okay. I kind of, whoa, this is too loud. Alright. So, what I have on the screen over here, right, is 2 pictures. So, both of these pictures for us look the same, but they're designed differently. Okay. Let me expand this one. Okay, so you see the difference in both. Both of these are tigers, right? But when I zoom in, you see that this picture, however much I zoom in, is clear. You see the crystal clear lines, okay? But if I look at the picture on the left, you'll see it's blurred, right? The difference between this picture, okay, and this one are that one picture pixelates when you zoom into it, the other picture is crystal clear when you zoom into it, right? Now, the reason being that this picture on the left, okay, is what is known as an RGB picture or a red, green and blue, and I will explain that shortly. So there are two types of pictures. Okay, there's a what is known as a raster image and a vector image. Now, raster images like this one are what cameras generally capture. The cameras behind our phones, the cameras, this type of camera, all of it is capturing the visible spectrum of light. So you have your red, greens, and your blues. So all of this is capturing that visible spectrum of light and then converting it back into the pixels that you see, which translates into images. This picture over here is not based on pixels. It's based on mathematical calculations, right? So these are vector-based parts. So there is something called a raster image and a vector image. The raster image is based on those RGBs. So you have your red, green, and blue, okay? And you see this red, green, and blue set. That, in computer terms, is known as one pixel. You would have heard of pixels, right? There's an entire movie on it, pixels. Right? So that entire thing is having that red, green, and blue layered on top of each other that gives us the color. Let me show you something interesting. This is the next section. Okay. Now, what do you see? Anyone, what do you see? Colors, red, green, and blue, right? Okay. Let me just zoom in. Now, what do you see? It's pretty dark because but you can basically make out it's a picture, right? It's a picture of me. Let me see if I can enhance the brightness a little bit because you can't make out from this, the projector doesn't capture it correctly. But this is basically made out of pixels. Each set of lines that you zoom in is one set of lines is red, one set of lines is green, and one set of lines is blue. Right? So you can kind of see that. So the reason you're able to convert that, in your brain there's all the work. It converts the image that you're seeing, these pixels, individual pixels that you're seeing, your brain automatically converts it into a picture. Right? You don't have to think about it. And that's the entire process flow of being able to say, okay, everything from white. So all of pixels range from the values of 0 to 255, 0 being black, 255 being white, and a range in between. So if you take a grayscale image basically is made out of those pixels of between 0 to 255. Right? So majority of the studies or the computer vision that we're doing or the libraries that we have, because the creation of vector-based images is difficult, right? You need advanced maths in order to actually create an image like this. There's a lot of parts that have gone into it. Capturing images which is in RGB, common cameras can do. So majority of the research in the terms of the what, where, and how are in lines of actually doing identification on raster-based images. So what are the tools we use? Now, we can use multiple programming languages. I personally generally use Python, right? Because it's very, very easy to use. It's simple to run. How many of you know Python, by the way? One? That's it? Nobody? No? Okay. That's probably one of the courses that you're going to have to take. Okay. So we'll be using Python during the hands-on. Okay. And of the vision libraries, you can do tons of stuff with OpenCV. Right from image manipulation, image detection, it's got neural networks built into the library. So you can do object detection, you can do image enhancements, you can do edge detection, it's called canny edge detection algorithm. You can identify line with hue lines, you can identify circles with hue circles. I basically normally take an entire course on OpenCV with everything starting from the basics right up to the end. But with today's session, I want to kind of give you the ability to give your computer a power of sight, right? And I'm going to be using MediaPipe Studio because MediaPipe is by Google. It's a library that has come in recently, which is a lightweight library built on the computing engine of JAX, which is also Google's computing engine. So, is somebody named JAX over here? Yeah. So basically, it is a collection of libraries that you use in order to get things done with computer vision. Okay, it just makes things a lot easier. Right? So let's get into the work. What do you guys see on screen? And a mouse? Why do you say that's a mouse? Because it's a mouse, right? What's the difference between that mouse and that mouse? They're both mouse. Right? We just automatically associate except cat, dog, and mouse. Right? So, what's the difference between that mouse and why do you say it's a mouse and not a rat? It's a mouse, not a rat. What's the difference? It doesn't have pointy ears, rats have pointy ears. Right? Mice have rounded ears. That's the difference between a mouse and a rat. Right? So, as soon as I. Okay, so you basically said it's a mouse, and that's. Right? But how do we as humans know the difference? How do we as humans actually perceive the difference between what is a dog, what is a rat, and what is a mouse? We know that, but how do we do that? Has anyone thought about it? How do we know that? From our parents, right? So basically, when we are children, and when I take my son for a walk in the road, and my son's name is Kiran, so I basically tell him, say, see, there is a dog over there, or see, that's a cat over there, and from the time they're small, we basically train them to know the difference between animals, right? And that's the power of our brains, our power to remember when our parents tell us that's a dog, that's a cat, and that's a mouse. But there are different types of cats, there are different types of dogs, right? Dogs come big, dogs come small, dogs come in medium sized, Dachshunds are long, dogs, white Dalmatians are white and black spots. But we still know that that's a dog. Right? Cats have different colors, there are orange cats, there are darky cats, there are Persian cats. But we still know that's a cat. And we are still being able to make out the difference between a dog and a cat. Okay? And in order to teach the computer that's difficult. So how do we do that? The whole process of being able to tell a computer how to identify what item there is in the picture that you're looking at is built using what is called convolutional neural networks. Anyone knows what neural networks are? What are neural networks? No, I'm going to have to cover that. Okay. Neural networks are basically pieces of, or think about our human brains, right? So, in our human brains, what are neural networks? Let me just walk over. I don't have that PPT, but let me just walk over to another day. Sorry, I've got tons of presentations that I have because okay. This one. Yeah, this probably would be. Look, this is. So basically, neural networks are pieces of information that are neurons in our head, right? So that are stitched to each other. I don't want to go deep into neural networks, but our brains, right, are built with neurons. So there is a neuron that stores information and then transfers that electrical impulses down to the other neurons and to the other neuron. So basically, when we go down into a neural network, right? So we pass in the inputs over here, and then there are hidden layers and there's an output layer. So you can have multiple hidden layers, multiple output layers because our brains have multiple neurons in it. So it's not just one layer of neurons, otherwise our head will be really flat. Right? We don't have flat heads, we have round heads. So basically we've got multiple neurons, layers of neurons in our head that transfers over impulses, electrical impulses that go from one to the other to the other. That's basically what is known as an artificial neural network. Right? That's how an artificial neural network is built. I'm not going deep into how to build one, just keep in mind that we have artificial neural networks. Okay. And an offshoot of that artificial neural network specifically for images is called a convolutional neural network or a CNN. So the way that it works is slightly different because you have to pre-process that data into doing what you want it to do. So it takes the data and passes it through 3 different types of stages and layers. They're called convolutions, pooling, and your fully connected layers. The easiest way to implement or to visualize this and this part of it is really good. So this is how a computer actually visualizes data. So if you see this, like I'll draw a number over here, right? So this is trained on what is known as an MNIST data set, which is a collection of people who have written handwritten characters and now gives a computer the ability to recognize those handwritten characters. So say for example, I draw the number 2. Right? It's correctly identified it as a 2. So if you look at my first guess, this is what I've drawn. My first guess is a 2. Now, how does it identify it as a 2? So it basically takes pieces of information from different areas of the image, okay, and puts them through a processor that ultimately comes up with this unique data set, right? So it goes and it flattens the image, it flattens the images again, it goes through a downsampling step. It goes through a fully connection step and then a pooling step, and then it basically goes through a convolution to ultimately come out to an identification of whether it's a 2 or not. So we can do this with any of the character sets from 1 to 10, so or 0 to 10. So if I put in a 3, it's going to give me that it's a 3. Let's try and confuse it. That's a backward. But it says, it guesses, but it's not trained on this character set. Right? So basically, it's trying to figure out a best guess as to what could possibly be the image that I've drawn, but it's not able to. Okay? But in our brain, what did we think this was? As humans, what did we think this was? We are able to identify that as a backward thing. Right? So computers are able to only identify information based on what we feed to them. And this is fed characters from the 0 to 9 classification. Right? So the way this convolution works is kind of takes information from the image that I've put in over here, okay, passes it through that pooling layer and then again through a max pooling layer and then a downsampling until it reaches down to one line. So this is now brought down to that one line, which is again downsampling in order to give us that information that there's not. Let's try zooming. So I don't think you can zoom that. Alright. So that's basically how convolution neural nets work. Now this answers the question, what? So if you want to try this out yourselves, okay, I've got an example and I'll probably share this presentation with you later. This is an example of using TensorFlow as an image classification. So this example is on various flowers. So this basically does a classification which you can try out on your own on Google Colab. Okay, it's already a written code that you can probably take over and run the example step by step. It gives you a ability to train the convolution neural net in order to build an image classifier for flowers. So, are there any questions with the what? Right, so, what we do is image classification, and how we do it is using CNNs, convolution neural networks. Okay, to identify what there is in an image. Okay, let's go on to the where. So we need to identify where items are. Remember that we can identify what those items are. So there is something called as a sliding window approach. So effectively, the way this does it is it segments out the image into separate pieces of the grids. And once you get those items on the grids, you're able to look at individual pieces of that grid and identify what those items are, right? So you know what the items are from CNNs. So now if you take that over, so if you take that over, right, and then divide that image into a grid, and then pass that image from each item on the grid and identify, okay, is there a cat here? 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 You'll be able to then identify where the cat is. That's how the basic concept of being able to identify the where part. But that's difficult because first of all, it's computationally intensive to run a convolution neural net in every single grid point, and that's the reason they have come up with various algorithms to do so. So there are single shot detectors, there's a YOLO classifier, there's a fast region classifier, an RCNN, and there's a retina net. Now these are CNNs, but they are different types of CNNs that are written mostly for competitions in order to get the best time in order to identify where items are on an image. Okay. So let's pick up. So we move on to media files because media files are great to hear about this. So once it loads up, you'll see me. Okay, you'll see that it will probably identify me as a person. The camera is moving up. Wait for that. So you see this? It is identifying me as a person. Okay, it is identifying. It's able to actually see the projector. Okay, it's able to see the laptop. It's saying that there is a laptop, and it's saying that I'm wearing a tie because I've got my mic over here. Kind of looks like a tie. So this is kind of what I'm talking about is object detection. The computer is now able to detect what is happening. So you can kind of see that it is saying that that's a TV because it's looking at objects on screen, right? And this gives the computer an ability to identify where they are in the overall frame of things. Now, since we know what items are, where the items are, right? That gives us a lot more context. So think about it from a point of view of a self-driving car, right? What does the camera in front of the car need to identify? It needs to identify whether the person on the road is a person, whether it's a cycle, whether it is a car, right? What speed I can go, because people have different walking speeds. Cycles have different moving speeds. Trucks have different moving speeds. Now, that is important when it comes to determining the stop distance, right? You don't want to slow down too much because you can probably get hit by a car behind, but you don't want to slow down too fast because you'll have to judge the distance to the traffic that is in front of you. And these type of object detection systems help when it comes to doing identification of cars. Object detection also comes in medical domain when you are looking at different cancer cells, right? So you need to be able to pass an X-ray image or a CT scan in order for it to identify whether it is cancerous or not, and the second, where that cancer is. those items are used, or object detection like this is used very heavily in all types of industries. It's used in healthcare, it's used in identification from satellites to find hotspots when it comes to cloud cover. All of those things come in the way when you're using object detection. Let me close this. So, any questions so far on object detection then? So, right now we've been talking about 2D images. Right? We've only been talking about 2D images. But in the not very recent past, IntelSense came out with things like the 3D camera. How many of y'all have played with Kinect on the Xbox? Okay. So there is a device. Basically, you stand in front of it and it's able to identify where you are, what you're moving, what your speed is. Okay. So it basically builds a 3D model of you in its memory in order to. It's a really good game. You can actually play bowling, you can play cricket, you can play tennis with the Kinect without actually having anything in your hand. Like I think the PS4 came out with the Wii, and Microsoft also came out with the Wii. So basically, this is how the Kinect kind of looks. It's also Intel RealSense also uses the same thing. It basically uses two different cameras because we have two eyes, right? And we are able to identify them. They're able to see how far things are from us. So basically, what they've done is they've done kind of the same thing to use what is known as time of flight, right? To have two different sets of points of view from a fixed distance to be able to identify the object in front of it, and then from the differences in those objects, the differences of the image between those two cameras, are able to identify them. Apart from stereo cameras, there is also LiDAR or laser detection, right? So there is also the radio detection. You would have heard of radar, right? On ships, on planes, you have radar. So similarly, there is something called LiDAR or light ray detection. What it does is it sends out a laser signal and it looks for the response back. And it's way more accurate than a stereo camera, but it's also way more expensive. So effectively, what you do is, and I've worked with LiDAR cameras before, they're really cool. Because you just place a camera and then it automatically maps out the object in front of it. And then you can use a Python library like Open3D in order to take that information and convert it into, it captures both RGB as well as depth. So now you've got a where in both the X, the Y, and the Z directions. So that's where 3D computing is upcoming, and it's a really cool thing to have. So apart from 3D computing like this, you have depth, temperature, thermal vision as well. So you've got normal RGB images, you've got 3D images, and you've got thermal images. Now with so much of power that we are transferring to a computer, we need to be able to process that information. So another thing I kind of want to talk about is, as humans, we read, right? We are able to read text in front of us. And that's also important when it comes to being able to give a computer the power of sight, because we're able to see things. And we're able to automatically, our brain processes it into text and gives us textual information from it. Right? It's not just image information anymore, it's data as textual information. So there are two parts to this. One of them is detecting the text, and one is converting the text into text strings. Because computer programs deal with those text strings. Right? So we're able to take that computer, or take that image, pass it through algorithms like the FAST algorithm and the East text detection algorithm. It gives us as XY coordinates of the text information. So you basically, if you look at this image, I've put in links to both the GitHub as well as the OpenCV libraries that are being used to do this. They're really cool experiments to try out. So you can take any image, pass it through, and it'll tell you where the text is in that image. And also, we can use OCR or optical character recognition. TestRec is open source, TestRec is free. You can use a TROCR, which is a new Gen AI based transformers approach to converting text from both printed as well as handwritten character sets into textual information. Right? We've actually used TROCR on a really cool project for a Swedish-based company where they wanted to digitize documents. Now, they were struggling with digitizing these documents because a lot of that were handwritten. So, these are these electrical installers who go onto the field and collect customer data. But all of that customer data is handwritten, so they scan it into the system. But since they scan it into the system, now it becomes difficult for them to actually convert it into textual information, right? Because now they want to push that information into the database, and they can't because it's image data. So we wrote an algorithm in order to use TROCR, both with FAST and TROCR, to pick up those pieces of information, pieces of text, identify what they are, and then take that information and push it back into the database. Tesseract only works with printed characters. TROCR works with both printed character sets as well as handwritten. Okay, so that kind of covers the what and the where. So basically, any questions on that? Or am I basically bored you all out totally? Really boring session, isn't it? Okay. So, any questions so far? And please feel free to ask questions. I hate standing and talking without people asking me things. So, any questions? No? Okay. It's a really fun field, at least for me. I'm in this industry, so it's a really fun field for me. And because I get to be able to tell people that I've done stuff which, have given computers the power that only humans have so far. So the next thing is a pool, right? And, yes. Pull this thing. Right. So now, for us, identifying people is easy. Right? It's extremely easy to look at a person next to us and automatically our brain gives us the name of that person. But computers don't know that. Computer does not have the facial recognition capabilities that we as humans do. So how do we teach a computer to do that? How do we, and that converts to this thing, how do we recognize our friends? We pick up unique characteristics. That guy's got a big nose. That guy's eyebrows are too close together. I'm fat, right? So effectively, and right now I'm balding, but yeah. So effectively, it's characteristics of people that we pick up in our mind that give us an indication of the person that is in front of us. The same characteristics is also used in facial recognition. How close our eyes are together. What is the difference between our eyes and our nose? What is the difference between our nose and our mouth? How far our ears are spaced, right? All of this is unique characteristics that each of us have in what is known in studies as a 128D. And now it's actually gone to 512 dimensions of measurements that we take on our faces that tell a computer who we are. Right? I've built a system, let me see if I can pull that up. So before I do that, here it is. And that's me. Right? So that's also me. So what does that show? That basically applies face mask to my face, telling me what dimensions are. So it's moving with the way I speak. So if I close my eyes, it closes its eyes. If I open my mouth, yeah. So basically, the red and green state the left and the right eye positions. The grid points that you have in the grid and the lines, those are the distances of key features that you have in our faces. So we can take those key features and put it into a vector and then take that vector, compare that to another person's face, you can then make the distinction between a project that I should have pulled this up. Command system. No, this is my system. It's not good. Yeah, I want the Anaconda account. Okay, basically what let that load up, okay, and then, so what I kind of want to do is, so effectively we measure that as a vector, right? So once we can do that as a vector, there's too many windows open. I think I'm running too many things at the same time. Let me close this one. So until then, any questions that you have? No, all good? Alright. Let me see if I can bring that out. What I want to do is, we did a project for attendance-based system that we kind of have. So I use Anaconda sometimes when for personal use. It just makes things a lot easier. But effectively, what we did was we had to write attendance system. Like, so, you know, when people come in, y'all have the bigger swipey thingy to record your attendance. You all, at least the teachers do over here, I believe. So if you look at this, what it does, it basically recognizes my face. Okay. So let me pick up a picture of. Let me try Will Smith. I'll put it in front of the camera. Right. So effectively, it who? I don't think I have this picture on the internet. Okay, so this is what it does. So basically, it is able to recognize me. So the way that I've trained this is on tons of pictures. So I took these pictures that I have over here, okay, passed it through an embedding system that is able to extract the feature embeddings, convert that into a 128D vector, and then take that image that I'm getting from the camera, also look at the 128D vector and compare it. The closer those are, the more you know that the person is. So I can take any picture that is in here. If I take a picture that's not in here, it is basically going to tell me unknown. Okay. So you can also see that it is doing the detection based on, if I'm not in the screen, it's not doing the detection, right? So if I come into the screen, it's detecting my face. So I've used a very lightweight classifier for the hard detection, the hard masking in order to do this, right? It's not a deep learning algorithm, it's an algorithmic way of doing face detection. It's called hard cascades. You all can probably research that part of it out. Okay. So that kind of covers the theory part of it. So any questions do you have? No? No questions? Alright, who wants to try the hands-on session with me? Who knows Python? So we're literally going to go hands-on. I mean, very literally. So what I've actually planned to do is, hand detection. So in the starter pack that I gave you, okay, if I complete the setup run,
Yes, sir.
right? It's all done. You have reached this thing at the bottom saying please wait. You've hit on that. So all of that's done. Okay. Now if you run the second one, the run cv.bat, I've just so today I've just been running too many models, I think. Okay, so what this is doing is it's loading up a media. So I showed you the media pipe where you saw the face recognition. So they've got also downloadable models that you can use on your system. Okay, so if you look at this, right? So this is kind of some, the Tony Stark Avengers level stuff that he does, right? So basically what you've got now is an ability to determine. If you look at this, it actually tells you what it's doing with my hand. My hand is open, my hand is closed. So I can identify B, I can identify a pointing up, I can identify a thumbs up. So basically there are identifiers that happen. So this is a thumbs down identifier, this is a thumbs up identifier, right? So you can, if you run your own program, you will get to this stuff at exactly this point, and you'll be able to do this on your systems right now. Get it? Not running? It's running? Okay. So this is the cool part of computer vision which you can actually do. So what I kind of have here is just the basic detection, very basic hand detection system. Okay. So what I kind of want to do now is to be able to use. How many of you have thought about controlling your mouse with your hand? Not with the touch screen, just with your hand. Do this and then your mouse moves. You want to do that?
Yes, sir.
Right? So if my mouse will move. So let me do this. I'm going to turn on the light over here because it's really difficult for my camera to see. You won't be able to see the screen, but can you see the screen? Yeah, because now the camera kind of is easier to identify. Alright, so anyone's having a problem getting this up on their laptops? Yeah, I come over there. Ma'am, you want to turn the camera off? Can I do it? Because I probably need to step in and hit about the people there. Otherwise, you will just be a blind. Okay, so I'll leave this on. I'm going to come over and okay, then. So, you can just check. Okay, fine. Just run this one. No worries. Yeah. So you set up that. Yeah. Okay. Let me try. It'll take me a bit of time to get set up manually. I Oh, it's not funny. Complete the run. Don't need that it is just you need to get that. Anyone else? You asked me to download this. I think this is fine. This is perfectly fine. I actually leave this for my son to play around with it, you know. Network is really strong. All right, anything else? All right. So I basically put in two. I put in two libraries over there. Okay, one is MediaByte library recognition like this. Okay, and your file if you can't get it now, it's okay. If you want to do it later, you can do it later. So effectively, what I've done is I've put in two libraries. One is the MediaByte library for hand gestures. You can also do image recognition. You can look at the loaded models from the MediaByte library. Okay, to do other things as well. Let me show you a couple of other things that I can do. Okay, so this is another thing apart from hand. This is your full body, right? So you can also do full body recognition. So this is my son keeps going up and down saying, skeleton is following me, skeleton is following me. So effectively, if I want to keep him busy, I just put this and then put it on full screen mode and let him go run up and down in front of me. So effectively, you can do things which pose recognition, right? So you know where people are. Now remember what I was talking about where? Now this gives you an option to tell where those people are in connection with the pictures that you have, right? And this doesn't just recognize one person. Right now it is. But you can actually do this with 2 or 3 different people as well at the same time. So right now, I thought I would, if you're already, I thought you're well versed with Python to be able to actually take this as a hand-on exercise, but maybe you can try this later. So go to ChatGPT, remember we're talking about ChatGPT, and ask it that question, say, using Python, how do I move my mouse on the screen? Okay. So it will, in most likely of the cases, give you a PyAutoGUI library, and I already have that installed in this one. So if you want to try that out, and since we're doing an AI-based thing, let's try it out. Right? So we go to ChatGPT. See, it's going to basically tell me use PyAutoGUI library, and I've already installed that file. So in the packs that I've already given you on the starter pack, you've got MediaPipe and you've got PyAutoGUI installed. And it's basically given me the code as well, saying how do I move my mouse. Now you just need to write an algorithm in order to tie both of them in together. So you're able to identify where your hand is on the screen. So now if I go back to this, right? You see this, let me turn off. The way this works is when you're looking at your hand, okay, your wrist ends at position 0. So when you're looking at the hand, you see those points. Now each of those points correspond to one of these items. So if you want to identify where each of your fingers are, you can do that using this map. So if I look at 8, this is the index finger tip. So this is the tip of my index finger. So now if I'm able to identify where the tip of my index finger is able to, and then use that position on screen, along with PyAutoGUI, I should be able to move my mouse on the screen. Let me take this one and move it back into my Python. So I'll just explain this code to you. I'm going to open it and show you the code as well. But for people who aren't very well versed with with programming, it's going to be a little difficult. So effectively, what I've done is the only thing I changed, and everything else is the same. The only thing I changed is this. Using PyAuto, I to get the size of the screen because I need to know where to move my finger, right? And I can move my finger within the window that I have. But I need my screen is larger than my finger. So I have to change that as a scale factor. So effectively, I've taken a scale factor to determine the size of the window and the size of this camera screen that I have because I've got an image of where I'm moving my finger is smaller than my camera screen, than my screen size itself. So I need to scale that up. So that's what I've done. I've taken this as a scaling factor. Okay. And then this is all standard stuff which you can go through. It's landmark detection. So getting the hands, getting the landmarks, and all of the drawing stuff happens over here. And it's already there in the code that I've given you. Yes, this statement which is on 71, that's where this thing goes. So this is the move to, and that ChatGPT will also give you the same thing. Okay, so it's basically move my mouse to these coordinates. Right. So I'm finding out where my hand is. So this number 8 you see over here, that's the 8th position of that array, which tells me where the tip of my finger is. As long as I know where my tip of my finger is, and that I am pointing that finger up, right, and know where the tip of my finger is, I know exactly where my finger is on screen. And by tracking the position of that tip of that finger, I'll be able to move my mouse because I'm able to use the PyAuto GUI move to in order to move my mouse. I've also added in a click function, right? So if, as long as my mouse is at that point in time and I close my hand, now it becomes a closed fist. Now I've got a pointing up, I've got a closed fist right now. So I'm able to identify that I've closed my fist and then I'm able to actually click. So using code, this is a project that I wanted to do when I was in college, and I tried doing this with colors. So I took a pen with the colored cap and then tracked where the color was. Because at that time I didn't have a way of actually using my hand in the gesture recognition device. But I was able to do it with colors, and I just did the same type of transformations in this. This is the base file. I just want to replace this file with my So the files that you have in your code is in the program files directory. So you've got two files in there. This is for my next session on speech recognition, which we'll do on a hands-on. The first one, which is the CD gesture recognition, that's the one that you will code. I can probably give you a idea. Try it out. So this part of it is fun, right? So you basically, it's more of algorithms. So once you're able to actually do one thing, you can connect it to other libraries, you can connect it to other items, right? And if you look at my mouse, you see my mouse also moving, right? That's the me being able to move my mouse with my finger. You see that red circle that I have? That's the position that I'm using in order to track. Which means that if I click, it's actually going to click. So it's being able to use my hands in order to control my mouse move. Right? And that, I believe, is really cool. there. I haven't given you the Python code as such, but I can send it to you. How do I send it? I'll send it. Okay. So you all will be able to do a lot of cool stuff with this. It's just, I give you the base. Now it's up to you to build on top of that. Python is a very versatile, very useful language. So if you want to learn Python, there are several courses that you all can take. And in the area of AI, in the area of machine learning, knowing Python is the base requirement of being able to get any. There are several other no-code, low-code platforms that you can use. I'm pretty sure people will talk about them in the upcoming sessions. Like Nine, for example, Orange. So there are several other software that you can use to do no-code based platform, but machine learning as well as deep learning. But if you want to actually get ahead, I would seriously recommend learning a programming language, because that gives you the flexibility that you have when you want to build up application. It basically took me like 3 hours to put together for the demo, right? And it's really interesting. So I would recommend learning Python, being able to get good at those algorithms and stitching things together, right? Think about a project that you want to do, say a to-do list, but try and do that with voice, or do that, the deletion of those items, the addition of those items with hand gestures. There are a lot of powerful things that you can do as long as you have the imagination to do it, and your imagination is limitless. So use that imagination, and I'm sure each one of you are going to do it, except for the people person, which I can see from here. All right. Okay, sure. That's kind of ends that session that I have. I think I'm on time. Am I? Yeah. All right. So if you have any questions, please do ask. My email address as well is on screen. So you can drop an email to me, say that you're from East Point. I will be happy to answer any questions that you have from a technical standpoint, or project-wise, or if you just open to discuss, want to have a discussion with me. Fair enough. That kind of brings me to the end of my session. Thank you very much. Thanks for
Computer vision, a type of artificial intelligence, enables computer to interpret and analyze the visual world, simulating the way humans see and understand their environment. Applications of computer vision range from simple to complex examples. Examples are facial recognition, robotic automation, manufacturing of fall detection, etc. Thank you, sir, for the information on computer vision and hands-on experience gained by the participants. Thank you. Students, all the participants will go for the lunch break and come back for the next session. Please wait. Students, please wait. Participants, please wait.